Hello guys, how are you? Let's have our another session. I'm so excited. Look at this library. This is my favorite room. This is my lovely library. I don't have it, but well, I wish to have. This session is about one-dimensional motion. So we are working in just one dimension, and let's say just x dimension, x direction actually, and yeah, that's it. And we will have our formulas about the speed, acceleration, is analyzing the motion of an object in one dimension. So we would have also some kind of shortcut formulas that people usually memorize them. Let's go. Okay, guys, I'm going to talk about one-dimensional motion. Two concepts we're going to talk. One is displacement, the other is velocity, average velocity. So, first, displacement. What is displacement? When you move from your initial point, let's say xi, to xf, when you move forward, for example, from from xi to xf, then delta x would be your displacement. What does it mean? If I want to show it on a coordinate, which is in one dimension, let's say x, this is the 0 point, and this is 1, 2, 3, 4, 1, 2, 3, 4. So you want to, for example, move from 0 to this 3. Then this 0 is your xi, initial point, final point. Then your displacement would be 3 minus 0, which is 3. Let's say meter. Okay, this is your displacement. So if I, for example, let's say this is again x 0 point. If I would go forward from this place, my initial point, and then return, then as you can see, my xi equals xf. Then my displacement would be 0, as you can see. Okay. Now let's go to talk about average velocity. What is average velocity? Average velocity. Actually, average velocity is the average of your displacement over the time it takes. What does it mean? V bar equals delta x over delta t. Your displacement over the time it takes. xf minus xi over tf minus ti. If I want to show it on a diagram, it would be something like this. 0 point, again 1, 2, 3, 4, and for example from 1 you're going to 4, and it takes actually 3 seconds. So your displacement is here 4 minus 1, which is 3. And your time is also 3 seconds. So your average velocity would be 3 meter over 3 seconds is equals to 1 meter per second. This meter per second is the dimension of velocity. So now let me write down a nice example. It's a great example. Listen carefully, please. So for example, I This is my, diagram for average velocity and time. Average velocity and time. Now I want to take a journey from the beginning. I am taking, for example, this amount of average velocity. Let's say it is 2 meter per second. And let's say it takes delta t 1, it takes just 2 seconds. Then after that, uh, we have this average velocity, 4 meter per second. Let's say it takes, for example, it is 2, it is 3. Well, it takes delta t 2 equals 3 seconds, 1 second, sorry. And then here, this, and this is, for example, 6, and delta t3 is 3 seconds. And also here, it is 1 meter per second. Okay, I have these 3 parts. What would be the average velocity in total? Total average velocity, what is it? Well, to calculate this, I'm going to calculate total displacement, which is the displacement of the first part, second part, and third part. For first part, which is this, uh, my average velocity 2 meter per second, and the time 2 seconds, well, I'm going forward 4 meter. Then after this, delta x2, 4 meter per second times 1 second equals again 4 meter. And the last part, which is the third part, 1 meter per second times 3 seconds. Then it is 3 meter. When I add all of them together, delta x total will be 11 meter. Okay, 4 plus 4 plus 3. Now I'm going to calculate v bar total, which is delta x total over delta t. The total times it takes delta t, which is this 3 seconds, plus this 1 second, plus this 2 seconds. So 11 meter per 1 plus 2 plus 3, which is 6 seconds. So it would be somehow, 1.8 meter per second. So this is my total average velocity. Remember, what matters here is the displacement and the time it takes to be able to obtain average velocity. Okay guys, that's it. We'll continue one-dimensional motion next session. See you!